Okay, good morning. Thank you for joining us on our webinar on BACnet. It's roughly about 15 minutes presentation, and we'll go into a Q&A then. As usual, if you've any questions at any point, you can put them into the questions panel, and we'll get to them then. We'll get started.
Welcome to today's tutorial. Let's get started. Let's take a look at our agenda for today. We'll talk about BACnet and the building automation market in general. We'll discuss BACnet's history, how BACnet works, and how you might use an OCS All-in-one Controller with a BACnet application. We'll demonstrate configuration and programming with BACnet, and as always, we'll finish with a live Q&A session. So, what is BACnet? BACnet stands for Building Automation and Control Network. It is the most popular network for building automation installations. The building automation market is growing. The market size was approximately €65 million in 2019 and is projected to grow to €100 million by 2024. That growth is in part due to a focus on energy savings and energy conservation. In 2017, BACnet had attained a 64% global market share with a 52% market share in Europe. BACnet was created and is managed by the American Society of Heating, Refrigeration, and Air Conditioning Engineers. It is promoted by BACnet International. BACnet allows building management systems to interface with a wide variety of equipment across multiple manufacturers, as you can see on the right-hand side of this slide. Proprietary solutions from businesses like Johnson Controls and Echelon once dominated building automation. BACnet has replaced them in a lot of cases. Here is a timeline of the formation of BACnet. Although it has been around for a while, it is continuing to gain momentum. BACnet collapses the 7-layer OSI model down to 4 layers. It defines multiple options for media layers. BACnet is a very flexible network which officially supports 7 different media layers. The most popular media layers are BACnet MSTP and BACnet IP. BACnet MSTP is an RS-485 network, so it doesn't have the relay, the throughput, and the speed that you can achieve with BACnet IP. It's also more difficult to configure than BACnet IP. Most new installations use BACnet IP. BACnet IP uses standard switches and routers to connect multiple BACnet IP networks. As a result, BACnet routers allow MSTP and other physical layers to coexist with BACnet IP. You can use one of our products as a gateway to take a legacy network like Modbus and exchange data. In that scenario, data translation is required. BACnet uses an object model. It's based around devices that have objects and those objects that have properties. A BACnet device is a collection of a set of objects. The table on the right shows the 54 predefined object types. The object type defines a list of possible properties for that object type. An object is an instance of an object type. Our Horner products that reside on BACnet support the device object, analog input, analog output, analog value, binary input, binary output, and binary value. Now, in addition to defining objects and the properties within those objects, BACnet also defines services, which define how devices communicate with each other. There are 38 BACnet services organized into 5 different classes. There's alarm and event services, file access services, object access services, remote device management services, and virtual terminal services. Services within BACnet follow the client-server approach. The client in the transaction would send a service request, and then the server will send a service response. We've highlighted the services on the chart that we support on our Horner devices. While BACnet defines a device as a collection of objects, it categorizes devices into one of 8 types of predefined devices. These are device profiles, which define the expected capabilities for devices to ensure interoperability. These range from a BACnet smart sensor, which might be a temperature input, all the way up to the full building management system, which might be a BACnet Advanced Operation Workstation. At Horner, our products are BACnet application-specific controllers, but you could supply our product as a BACnet Smart Actuator or a BACnet Smart Sensor. Interoperability areas are the areas of sharing data between devices, alarm and event management, scheduling, trending, and device and network management. A BIB is a BACnet interoperability building block, which is a collection of BACnet services. It is prescribed in terms of whether that service is being utilized by a user or client device, or whether they are a provider or a server. This chart shows the different device profiles in the top columns, and then in the rows are the interoperability areas. Within each cell are one or more BIBs that define the interoperability areas along with the services that need to be supported by each type of device for it to be interoperable with other devices. Our products are application-specific controllers, which means there are a minimum of 5 BIBs we must support, which are highlighted on screen. To summarize the capability of our OCS products, in the first chart we show the different objects that we support with BACnet. A Horner controller supports the device object, which is required by all BACnet devices. It supports analog value objects from 0 to 5000, analog input and output objects between 0 and 256, digital values up to 1000, and digital inputs and outputs up to 256. We have a list of all the services that we support. The device parameters list is an example of some of the device parameters that we support for our device object. And the last charts highlight some of the I/O object parameters that we support. Now let's discuss how you might configure one of our products as a BACnet MSTP server. BACnet MSTP is based around RS-485. It will commonly be a 2-wire half-duplex network at a relatively slow baud rate, as it's a legacy network. If you're installing our product as an MSTP server, you need to match the port configuration with what's happening on the network by getting the baud rate, parity, etc., and setting them to appropriate levels. If you're using Service Pack 3 or later, then you can start, stop, and reset the BACnet interface on demand using a disable bit. We also have a status register, so you can assign a variable that will give you real-time information to let you know when you're successfully communicating with the network. After that, we go into the device level. You'll need to configure the BACnet device instance ID. This needs to be unique on the network, and the default is typically 1. Then you've got many device options for configuration. There are many options to configure, but in general, most parameters can be left at default level. To optimize performance, we recommend keeping 16 nodes or lower. We also recommend setting MAC addresses to be consecutive values, but avoid 0 and 1. You should also set max master just above the value of the largest MAC address. The final step is to configure which objects and how many of them we want to allocate for our device. You can allocate many instances of analog values, digital values, etc., which for performance, you'll want to keep to a minimum. Now let's take a look at BACnet IP. Just like with MSTP, we have network level configuration to do, but instead of configuring baud rates, etc., this is where we're configuring our IP address, netmask, etc. from the LAN configuration area. At the bottom left there's a downloadable protocol area, which is where you can select BACnet IP server as an option. The second stage on the network level is to strictly assign a disable bit to reset the network if necessary, and a status register where you can monitor the health of the network connection. At the device level, much like MSTP, we need to assign a device instance ID, which must be unique. The default is 1, but we recommend changing it. The configuration process for assigning the number and type of objects you want to support with your BACnet server is exactly the same as MSTP. So again, you can support the same objects with the same limits. The screenshots I've shown you are using register-based addressing for BACnet configuration. With tag-based programming, you're going to want to predefine your variables, for example your BACnet status array and your BACnet enable boolean. You'll create predefined variable arrays for your BACnet objects and map them to memory locations. Those array sizes are going to match the length of the number of instances that you need for each of those object types. Once you're done creating your variables and mapping them, then you can configure BACnet in your hardware config. Now I'll demonstrate how to configure BACnet in Seascape. I'm in Seascape and I'm using an EXL6W. Let's take a look at the LAN configuration. Now BACnet IP is an Ethernet protocol, so I've got to make sure that my Ethernet is fully configured, particularly netmask and IP address. And then I configure BACnet IP down here under the downloadable protocols. I've got this pull down list here, and BACnet IP server is one of my choices. And just like all downloadable protocols, we have 3 levels of configuration we can do here. Alright, so let's start at the network level. I'll leave most things at default. The only thing I want to configure here is if I'm using Service Pack 3 or later, I have the option of assigning a disable bit, which allows me to disable BACnet temporarily and re-enable it again. I would use this if I want to reset the port that's allocated to BACnet, and then I also have a series of status registers that I can assign. As you can see here, there's 4 32-bit registers. The main register we're going to focus on is the 4th of those. That register will be counting up when we get good BACnet messages coming into the OCS controller. Okay, so that's the network level. Now let's take a look at the device log. I've previously added this BACnet IP device here. If I had not configured it, I would hit the add button. I've already done that, so I'll double click here. This is where we give the device a name, which shows up on screen. Here in Seascape, the ID is actually the instance number for the BACnet object. This needs to be unique on the BACnet network. The port number is the standard port number that's used with BACnet, IP47808, and you can leave that alone there. Now since we've already assigned a disable bit for the protocol, we don't need to do that again here, so I'm done. Now on the scanless level, this is where we configure our object sizes. I'll double click here, and we configure the object sizes and where they're mapped for each of our different BACnet objects. The OCS supports the device object, analog value, analog input, and analog output objects, as well as the digital value, digital input, and digital output objects. Okay, so in this case I've assigned 4 generic word type registers as analog values, analog input type starting in AI33, with 4 of those from analog inputs, etc. Okay, so that's all the BACnet configuration that I need to do. Now let's look at the key variables for this sample application. This is where I've assigned my status register, where I can look at the good BACnet message counts counting up. This is where my set point for each of the 2 zones are configured, and I set those for the analog values that are sent over BACnet. And then these are analog inputs that are sent out over BACnet, AI33 and AI34. Now let's go over the network. In order to do that, I'm going to open a BACnet Explorer package. This is one of many different BACnet Explorer tools. One of the benefits of BACnet is that you can explore the network, and a tool like this can explore the network and discover what objects are supported, what they're named, etc. I'll right click and select Explore Network. I want to short circuit the search to keep it limited, and I'll limit it to the device object instance number that I've configured my device for, which was 1. It's a local BACnet network, and I'll hit OK here, so it's showed up right away. I can then expand this device. It'll ask me if I want to explore the device, and I'll say yes. Now it finds all the different objects that our devices support. You don't have to configure all of these things, but in our case, we assigned at least 1 instance of each of these in Seascape. Let's explore the device object. I'll expand it here, and there's some interesting information in here. Our vendor identifier is 600, our vendor name is Horner APG, and the model name is an EXLW controller. We've got the firmware level, what type of device it is, and it has an identifier of 1. Then we can also explore the other objects. We were using analog inputs to monitor temperatures, so in this case, present value of zone 1 is 22.5. There's an implied decimal point there. Analog input 34, which is zone 2, has a little higher temperature of 27.3. Let's look at our set point under analog value. Zone 1 was set in register 2001, and we've got a value here of 25 degrees. Let's change that to 26. I'll have to read that value for it to show up here. The instances of all these different objects are named after the memory location. So that was a quick demonstration of using an Explorer tool to look at an OCS controller configured for BACnet IP. That wraps up today's demonstration. Thank you for attending today's tutorial. The Q&A session will begin shortly.
Okay, nice and short this morning. I'm not seeing any questions coming in currently, so I will take you to my screen for now. Which hopefully you can all see there now. So we do have our upcoming webinars listed here, our Ethernet IP next week, followed by, followed by the Horner app for Android phones, and then into downloadable protocols the week after. If there's anything in that video or other videos you want to go back and watch, as usual, we do upload them all. So today's recording should be up by the end of the day, or if not, tomorrow morning. Yeah, that looks to be it for today. Thank you all for joining us this morning, and we hope to see you again next week. Goodbye.